Okay, I will try to get in time. So, ladies and gentlemen, good afternoon. My name is Schweppe, and I'm still 7 years the chair in a European activity called Clean Sky for one platform called ecoDESIGN Transversal Platform. And what is ecoDESIGN in aviation means? Well, if you have a look on that nearly old graphic, you see that most of the impact on the life cycle costs are directly produced in that way in the designing phase, in these 3 phases of a planning, conceptual design, preliminary design, and then the detailed design where all the systems and all are really implemented. And that means the time you take at the beginning will pay off in lower life cycle costs at the end after the lifetime is over of the airplane. And that means what matters and distinguishes ecoDESIGN technologically. And you know, there are a lot of very simple principles in the ecoDESIGN phase for an engineer. That means, for example, aviation industry takes really clear vision for modernization-oriented and repair-friendly product design, as well as for substitution for hazardous materials in regard to the REACH compliance. And of course, standardization of components and yes, a suitable design for sorting and testing, as well as for wear steering on selected parts where corrosion or whatever could take place. But one of the really most important tools for the final improvement, proof of sustainability is the life cycle assessment method. And that is only, it's not a rocket science, it's just a tool already developed, and you can easily compare results from different technologies in relation to the final impact to the environment. And I will show you some ideas behind. So you see here this typical closed loop cycle in regard to closed circularity. And that means after lifetime, you should also be able, of course, to reuse a lot of parts for a second lifetime or using them only as a resource for making new materials through melting or whatever. And it's a sustainable aviation is not only reduced to carbon dioxide emissions or to NOx or to noise emissions. No, it's really more. And that means also you take a kind of a responsibility also for hazardous materials as well as for socioeconomic aspects. What is a working place in the future factory, of course. And that is already combined in the so-called life cycle analysis combined with the design for environmental called 2020 plus guideline. And I will show you some principles. Here, I'm sorry for the bad quality, but you see, if you are talking about life cycle assessment, that means that you have to collect a lot of data and really detailed data of the certain processes, as well as starting from the raw material, producing all these metals, these polymers and so on, and all these chemicals for production, as well as during the production phase process in the factory, and take also care after lifetime about recyclability of these materials. And that is, of course, a really challenge, because in some cases it's counter-current in targets, because you would like to have a really stable material during lifetime, but you also want to have a recyclability at the end. And that is, of course, really a challenge for future material developments. And yes, just have a look, for example, about the actual status in the so-called Clean Sky joint undertaking, the biggest European activity with all producers, aviation producers in Europe. And you see here, for example, at the moment we have around 200 technology pathways already in our database with around 550 processes. And it's not only just collecting data, no, there's a lot of algorithms behind to reduce it, to come to a kind of comparability of these different processes, always reduced to 1 kilogram of product or 1 square meter of a product. And that means you see here one example, that it's really a comprehensive study and also laboratory work to talk with the engineer to get all the status. And yes, here you see what efforts are made in the running Clean Sky activities, where all the 6 platforms, these typical modules of an airplane, have realized their certain flagship demonstrator as a representative of the most sustainable technology at the moment and for the future airplane. And you see, for example, large passenger aircraft with a multifunctional fuselage and advanced rear ends. All these components were collected, the data, then recalculated to bring it on the same comparability. Then you come to a life cycle inventory where all the data are comparable. And then you will come finally, of course, to the eco statement. And meanwhile, at the moment, we have more than 30 indicators which were calculated automatically if all the data are inside. And then it's not the duty of Fraunhofer to decide, okay, you have a part where wonderful small energy consumption has a problem probably with more cancerogenity of this part. No, we just calculate all this data and give them to the data owner of these flagships demonstrators. And that is, of course, then the turn back to in discussions with the companies to say, okay, these data we have to discuss about. What are the main advantages and main disadvantages? And you see, at the total, we got more than 30 flagship demonstrators during the last years, which were at the moment just in the final calculation. And you see here, the life cycle assessment is not only about the machining, it's also about additive manufacturing. A lot of technologies are meanwhile realized by additive manufacturing, which is wonderful because you can realize it without less material, buy-to-fly ratio and so on. But we are also talking about composite manufacturing, recycling management, and of course socioeconomics. What is a workplace in future? What is a business model behind if we are talking about recycling and so on? And finally we come to that analysis, and here I will give you one example of a Fraunhofer development together with industries. It was a strong target to realize seating structure made out of a monomaterial, which is then, after lifetime, more easy to recycle by a certain polyurethane system, which is recyclable. And we also were able to get rid of the flame retardants inside, because that polymer also already have intrinsic flame retardancy. And we got this year in Paris the JEC award for that. Yes, and coming to my conclusion, it means finally, yes, there are existing tools for final assessment of sustainability. They exist, they just have to be used. And yes, ecoDESIGN combined also innovative engineering as well with in the product planning phase to avoid the companies to have higher costs at the end, in the end of life. And yes, you see here this on the right, we do not have to paint environment green because aviation industry is really good developed. And that is just a challenge to use all these available tools for calculating the final sustainability. And I would say thank you very much for your attention.
Thank you, Rainer. And we have time for short answers on 2 quick questions. First one is, what are the consequences coming out from an eco statement?
Well, the consequences are not easy to handle because we from calculating size are only making the calculations. The final decisions have to come from the process owner. What are the consequences in regard, could we probably cannot use this flagship demonstrator in production because the disadvantages are too much at the moment. And that is the reason why it's organized in a big European activity, because that's the first time where eco statements were realized and directly, posted on real parts. So consequences are not easy to handle, but they will come.
Yeah. Okay, and how is a LCA practically, that means technologically, realized?
Well, it starts with a discussion with a responsible engineer at that point of the technical process, collecting data. Then the data are recalculated. And meanwhile, we have also realized in Clean Sky, how can we share data probably in the future? Because I have to say, these data are highly confidential. So they represent the know-how of a company. But in Clean Sky, we tried now, in Clean Aviation, we try to realize it in an aggregated way, that the data are comparable, coming from a polymer process or metallic process, can compare in a way that also other companies can compare them. But it is, to be honest, it took for Fraunhofer the last 3 years to accompany all these flagship demonstrators in calculation. And the final results will come next year.
Thank you very much also
Thank
for
you.
your question, for the
Thank
answer
you.
for the question.
Thank you.
Thank you.